Okay, hi everyone. I just wanted to make one note before you start this activity because I find that a lot of students have a really hard time with this. They accidentally switch it for some reason. So in this table right here, you're going to pick a mass, and I'll show you that in a second. And then you're going to vary the angle and then record the force and the displacement and then calculate the work done. So what I mean by that is when you get to this, it's all uphill interactive. You can pick a mass. So let's just say I'll pick 2 kilograms. And then we're going to vary the angle. So first I'll do 30 degrees. And then all you do is just click run trial. So you click the run trial, you'll note that the force is right here. So it says 9.8 newtons. That's our force that we're going to put into the actual table. And then the displacement here is on this hypotenuse of that triangle of the incline. So you can see down here we have a scale. So that means that every tick mark is 20 centimeters. So if we measure this, we get 20, 40, 60, 80, 100, 20, 40, 60, 80, and then we'll say 200. So that right there would be 2 meters. And I'll just measure from the back wheel right there. So what I would put here is let me go back here. I would put that 9.8 newtons in for my force, and then displacement here, that's going to be the distance that that cart traveled. So that would be 2 meters. Make sure that's in meters there. Now, when you're calculating work, I find that students have they always get confused and when using that equation. So work is equal to force times displacement times the cosine of theta. Now, here in that equation, you're not using this angle. You're not using 30 degrees for your theta. Remember, in that equation, force times displacement times the cosine of theta, theta is the angle between the force and the displacement. Here, that force is straight up this incline. So since the force is parallel with the incline, the angle here is actually 0 because the angle between the actual force and the displacement of the cart is 0. So all you're going to do when you're calculating work in this column right here is you're just going to multiply force times displacement. So in that case, this would be 9.8 newtons times 2 meters. And then whatever you get there, that's what, 19.6 joules. And so that's how you're going to calculate work here.